Welcome to Lesson 10, where the playbook meets reality. Over the next few minutes, we'll walk through 4 migration contexts: a load-balanced web farm, a Kubernetes cluster, a multi-region data center, and a legacy on-prem fleet running mixed RHEL 7 and 8. Same 8-stage recipe each time, only the emphasis shifts. As we go, keep an eye out for the scenario that looks most like yours. Here's the map for the rest of the lesson. Scenario 1 is the web farm, a blue-green cutover where the load balancer does most of the heavy lifting. If your environment fits, start here. 2 is Kubernetes, where HAPtables rules are generated by kube-proxy, and the CNI, so we roll out namespace by namespace. 3 is multi-region, where the real work is coordination. APAC first, then EU, then NA. And 4 is the legacy fleet. RHEL 7 at end of life, OS upgrade gating the firewall migration. Same 8 stages everywhere, the emphasis is what shifts. Before we go deep on any one scenario, scan this matrix and find the row pattern closest to your reality. Notice what changes. Fleet size jumps from 20 boxes to 1,000, timelines stretch from 3 weeks to 6 months, and the failure modes are completely different animals. Uneven LB drain versus a kube-proxy race versus region drift versus some surprise dependency hiding in EOL hardware. What doesn't change is the playbook underneath. Same 8 stages, just weighted differently depending on which column you live in. Let's start with the friendliest case, the web farm. 80 stateless servers behind HAProxy, symmetric workload, weekly maintenance window. The load balancer is doing most of the heavy lifting for you. You drain a blue batch, migrate it, verify counters match green, then re-add and move on. One GeoIP rule triggered a rollback at stage 6, but the LB absorbed it cleanly. 3 weeks, 0 downtime, and the team walked away fluent in IPsec. If your environment looks anything like this, start here. Kubernetes is where things get interesting. Same playbook, but now you're juggling 3 moving parts that all touch packet filtering: kube-proxy, Calico, and the host rules underneath. The trick is sequencing. Flip kube-proxy to nftables mode in non-prod first. Let it bake for a day, then bring Calico across. From there, Canary 1 namespace, usually dev, and walk it through staging to prod. 6 weeks, 2 rollbacks from a kube-proxy and Calico race condition, and 8% off your P99. The team comes out the other side genuinely fluent in cluster networking. Multi-region is the scenario where the technology basically gets out of the way. 1,500 servers across APAC, EU, and NA, 3 SRE teams, 3 change windows, and the hard part isn't the nftables rules, it's the choreography. You run it in waves. APAC first, because it's smallest and lowest risk, EU second, to harden the playbook, NA last with a field-tested process. A weekly sync passes lessons forward, so when NA hits a rollback, EU's notes already tell you why. 3 months, 1 rollback, 1 shared runbook, and a team that now knows how to ship across regions. Legacy on-prem flips the script entirely. 60 boxes doesn't sound like much, but when half of them are RHEL 7 with custom XT-type modules, the firewall migration can't even start until the OS migration finishes. So you sequence it. Upgrade to RHEL 9 first, clean up the shim state, then refactor to native NFT per role. 5 boxes a window, strict CAB, no heroics. 6 months elapsed, 3 rollbacks, and 1 custom GeoIP module quietly retired. Same playbook as the others, just stretched across an OS jump because the hardware demanded it. Step back from the 4 cases, and you can see why they keep showing up. First, topology drives strategy. A web farm wants blue-green, Kubernetes wants per-namespace, multi-region wants waves, legacy wants phased. Force the wrong shape, and the project stalls. Second, coordination outweighs code. Scenario 3 is technically easier than the cluster work, but the time zone tax makes it longer. And third, the hard scenarios, The legacy ones are where teams actually learn discipline, ship scenario 4 cleanly, and the rest feel routine. So here's your cheat sheet. Print it, pin it, hand it to your lead. Find the row that matches your fleet, take the budget as a rough anchor, and watch the column on the right for the failure mode that bites first. If you run HA pairs, adapt scenario 1 with a primary drain. If you're on hypervisors, treat them as legacy. And if you're hybrid, which most of you are, sum the budgets and add about 30% for coordination. The matrix is a starting point, not a cage. Now it's your turn to do the work. 3 drills, totaling about 2¼ hours, that take everything we've covered and pin it to your actual environment. Start by sketching your fleet on one page and matching it to the closest scenario. Most of you will land at about 70% fit. Then stretch the timeline by 1.3 for your first run, because every team underestimates. And finally, pre-mortem the failure mode for your scenario. Write the detection signal and the rollback before kickoff, not after the incident. Before you run those drills, a warning. There are 5 mistakes that happen one level up from the per-stage pitfalls. They're misunderstandings about how scenarios apply in the first place. Forcing the wrong scenario because it looks easiest, underestimating coordination cost on multi-team work, deferring legacy until the EOL date catches you, copying someone else's duration without scaling for your fleet size, and ignoring topology specifics like Cilium versus Calico. The fixes are simple. Combine scenarios, add a 30% buffer for coordination, schedule legacy first, scale outcomes to your fleet, and read the assumptions before you adopt the timeline. That wraps Lesson 10. 4 scenarios studied, topology mapped to strategy, timelines and budgets grounded in reality, and the common misapplications flagged before they bite you. The takeaway is the one we've been circling all along. Same recipe, different dishes. Find the scenario that mirrors your environment and adapt the playbook. Don't reinvent it. Next up, Lesson 11, rollback, testing, and formal change management. How to actually deploy this without breaking production. See you there.